Ooh, okay. Hi, Jackie. Welcome to the summer school. And I'm going to read a little short biography for you. I'll read a short biography and then it's all yours. Jackie Cheung is associate professor in the McGill University School of Computer Science, where he co-directs the Reasoning and Learning Lab. He's a Canada CFAR AI chair and an associate scientific co-director at the Mila Institute, which is a co-sponsor of this event. His research focuses on topics in natural language generation, such as automatic summarization, and on integrating diverse knowledge sources into NLP systems for pragmatic and common sense reasoning. In other words, it connects with many of the topics we've been discussing so far. He unfortunately, Jackie is also in an acute state of COVID, but he says he feels better today. So otherwise he would have been here in person. He also works on applications of NLP to domains such as education, health, and language revitalization. And he's motivated in particular by how the structure of the world could be reflected in the structure of language processing systems. With that, I invite Jackie to start.
Thank you very much. Thanks so much for this invitation, Stephen, and for the kind introduction. As Stephen said, I'm very sorry that I can't be there in person, especially since the summer school series is near and dear to my heart. I remember participating in one of these series around maybe 2016, 2017 on reasoning, and that was fantastic. So I'm really excited to have this opportunity to speak today. So today I'll be talking about benchmarking and evaluation in NLP. It's a topic that I've gotten quite interested in over the past few years, but I'll draw on examples from some of my work on natural language generation and automatic summarization as well. Okay, so the main question that I'd really like to talk about today is what does it mean when somebody says AI can do X? I think that's the theme of many of the lectures today. So I'm going to speak my piece, and then please feel free to ask me questions, and we can chat some more, and we can try to figure this out. And I think this is a very important question these days because there's so many conflicting claims about AI can do this, or AI cannot do that, or AI has learned this, or AI understands that, right? So it'd be nice to have some precision and some scientific rigor regarding what all of this really means. Okay, so as one example, I think this is the second time today that you've heard about Sabine Hossenfelder. So she's a YouTuber, a scientific YouTuber, and she's a physicist. And I think yesterday or the day before, she came out with this video called AI Learned to Lie Deliberately. And although it's maybe unfair that I'm holding her to a higher standard, it'd be good to ask what does it mean when you see like a popular science news article or maybe a press release from a company and they say something like this, right? Like AI learned to lie deliberately. And in particular, the study she cites and talks about in her videos has to do with AIs playing the board game diplomacy, which involves players taking control of countries and then making promises to each other and then backstabbing each other by not doing what they said they would do. And according to that study, and as reported by Zafina, this AIs that have been instructed to be honest and truthful nevertheless learned to lie in this game in order to try to win, because I guess that's their objective. Okay, but how do we evaluate that? So I'll put aside my personal opinions on whether those results in that study constitutes AI learned to lie deliberately. But I'm more interested right now in the more general question of like, what is the process of concluding from the evidence of that you get from experiments or observations towards being able to make that conclusion. And so the main point that I hope that you'll take away from my talk today is that claims like that need a lot of specification to be scientifically meaningful. So again, there's a distinction between people just saying things for the sake of, making a splashy headline or making something so that you click on the YouTube video. But if we want something that we can actually discuss meaningfully and fruitfully in a more scientific context, then you really need to drill down and talk about a lot more details in order to be able to assess that claim. So for example, when she says AI, you might be interested to figure out some of the basic details, like what AI, are there any restrictions on the type or the assumptions about how the AI was trained and what it was geared to do? You might be interested in what settings. Is it going to be in all settings or just in the setting of the game of diplomacy? What does it mean to lie deliberately? Like lying seems to involve intent. So that seems to presuppose that the AI knows the state, some state of what they're going to do, or maybe the state of the world, especially with the phrase deliberately. So that really involves intent. So do large language models actually have intent? And then also the next question after specifying all of these basics is like, what evidence is there in support of this claim with all of these specifications? And so today I'd like to talk about how we can connect these claims in NLP and AI more generally with experimental measurements so that we can usefully have a meaningful conversation. And I think, again, I want to reemphasize this is super important because I feel like a lot of the debates that we have in the field right now, whether it's about safety in AI or any other potentially controversial topic in AI, often people are not talking with the same assumptions and the same definitions in terms of the term for their terms. And when they draw on experimental evidence, there's not always a clear and consistent way in which they're doing so. And so I think that if we're able to add more precision in these discussions, that might help clarify some of these debates, and that might help people understand exactly where and how they disagree. Because it could be that they don't actually disagree much in terms of specific predictions about what AI systems can or cannot do in the near future, at least. But they might disagree on how to interpret it or how to interpret the evidence in support of what will happen, for example, in the longer term future. And because my area of focus and the topic of a lot of the lectures in the series is going to be about large language models and AI, in these fields, this evidence would primarily be in the form of applying, say, large language models to benchmark tasks using some data set and some evaluation metrics. And so that's what I'll talk about today. Okay, so as a high-level plan of this presentation then, so we've stated that the goal is to have a better understanding of what it means to say that AI can do X, focusing on natural language processing examples. And then I'll split this talk into two major parts. The first major part is to have a discussion of evaluation methods in NLP, and also to discuss these key notions in terms of measurement validity. So I am not assuming that everybody in the audience, although I can't see you, is in NLP. So I figure it'd be interesting or important to at least review some of the basic evaluation methods that are pursued in the field and are common in the field. And then in the second part, then I'll talk about something that's closer to, that is something that has come out of my lab recently, which is called an evidence-centered benchmark design, which is a framework to help structure reflections regarding validity when designing NLP benchmarks. And if you have any clarifying questions, please feel free to somehow signal to me. I assume that you can do so either through the
they can raise their hands. They can raise their hands here in the hall or on the list. And,
perfect.
And panelists can chime in directly.
Perfect. All right. So the first part. So the first part might be review if you're already in NLP, but I thought I would start by looking at common evaluation measures for large language models. And this will be one starting point, but it's by no means the complete picture. So one way to divide up the evaluation metrics or measures that are used is to think about whether they're intrinsic or extrinsic. So an intrinsic measure pertains to the particular task that a model was originally designed to solve, whereas an extrinsic one applies to some downstream application of the current model, such as in a task-based evaluation. So what do I mean? So let's look into a little bit more depth here. So for example, in classification or understanding tasks, you might have a model that, a large language model that was either fine-tuned or maybe using zero shot. But anyway, using it to solve some task that has been grouped traditionally into a sub-area called natural language understanding. For example, it could be sentiment classification or topic classification. So given a passage, you want to know or you want the system to predict whether that passage involves positive or negative sentiment. Or if it's topic classification, it might be like, is this article a news article or sports article, etc. And so popular intrinsic measures of this might include measures like accuracy or F1 score, things like that from information retrieval. And I'll give some definitions of that, although maybe many of you have seen some of these definitions. On the other hand, you also have natural language generation tasks, and that would involve tasks like story completion or translation or summarization, where some intrinsic measures might involve measures such as perplexity or some reference-based evaluations or computations of likelihood or human judgments. And so then in NLP, there's this distinction then at a high level between understanding tasks and generation tasks. But I just want to clarify that when people talk about understanding tasks, all they mean by that is going from, like the usage of the term just means to go from some language input to some output that is in a more abstract or structural form. So even parsing, for example, counts as a language understanding task in the way that people use this term in the NLP field. Okay, so for example, if we look at classification metrics, then what this usually means is that the setting is that you have a set of labels in your test set, which is annotated by, say, human experts, for example. And you want to compare the system's prediction performance to these gold standard labels with the assumption that the better the match, then the better that the system performs. Okay, so then accuracy is the simplest one. It's simply the number of correctly labeled samples divided by the total number of samples. But even at this very basic mechanical level, the point I want to make is that choosing accuracy as your metric is not a neutral value-free choice. For example, one very well-known issue with accuracy is that it can give a very misleading picture if the classes are imbalanced. For example, if you are in a spam classification setting, and it turns out that 90% of the emails are not spam, if you label everything as not spam, then you just get an accuracy of 90%. And this is the first way in which people can give misleading representations of the performance of a system, right? So you can see numbers like, oh, this has a 90% accuracy, 95% accuracy, and it doesn't necessarily mean much without context, because it's very easy to get those numbers in an imbalanced setting if you just predict the majority class label. So that's a very, hopefully by now this is very widely known, but still it's something to watch out for, right? But it's also, there are other assumptions here as well. So for example, accuracy, this notion of accuracy and all these metrics, they assume that each sample is equally important, right? And depending on purposes, that may or may not suit what you actually want to do. So none of these choices of metrics is a value-free choice. It's one thing I'm trying to say. Okay, and besides accuracy, there are other metrics that are widely used from information retrieval originally, such as precision and recall. So precision, for example, is the number of correctly predicted samples divided by the number of samples that have been predicted to be of a certain class. Whereas recall is the number of correctly predicted samples divided by the number of samples that are actually in the ground truth labeled to be of that class. And you can think of these notions as notions that are, they matter the most in a setting where a system has the choice to decide how many samples it decides to try to label. Okay, so if the system is just forced to label everything, then it turns out precision and recall don't matter. It's just the same with accuracy. But if you want to do, if you want to give the system the choice of what it wants to label, then you can compute precision and recall. Also, if you're interested in looking at precision and recall with respect to a particular class in your data set, then you can compute precision and recall. And also another metric that combines precision and recall is something called F1. So it's the harmonic mean of precision and recall. And the purpose of that is to prevent a system from gaming either precision or recall by itself, because it's very easy to do that. So for example, if you want high precision, you can just get the model to not label anything unless it's very, very certain. And then you can get close to perfect precision. Whereas with recall, you can get very high recall if you just get the model to label everything to be of a certain class. And for those of you who are working in medical fields, there are similar issues that occur when doing, say, having medical diagnostic tests or other issues like that. And so in the medical setting, there are very related notions called sensitivity and specificity that you might have heard of from that field. And so precision and recall are almost the same, but it's has the same general motivations for their definitions. So just as a quick example then, suppose here we have a table that tabulates in the spam classification setting, the predicted versus actual emails in terms of their counts. So for example, this cell in the top left means that there are 5 emails in your data set that were predicted to be spam and were actually spam and so forth. We can compute precision and recall and accuracy for this table. So for the precision of spam, for example, we would be interested in the first column where there are 5 correctly predicted emails that are spam among the overall predictions. So then precision here would be 5 divided by 20. Hopefully, if I type here, you can see. For recall, then you would look at the number of emails that are actually spam in the ground truth. And so here it would be 5 over 15. And finally, in terms of accuracy, it would be everything across all of the classes that are correct divided by the total number of samples, which in this table would be 25 over 50, because 25 because those are all of the diagonal entries which were correctly predicted no matter the class, and 50 because that's the total number of emails in this data set. So this just goes to show these numbers range from 25% to 50% for this made up example. And so there are many different numbers you can extract from this system applied to this data set. And you can report the ones that make sense for your use case or downstream purpose. So that was just a quick review of some classification evaluation metrics. Because we have limited time, I'm going to move forward and next talk about generation metrics. So this is becoming more important now that large language models generate text and we're using these texts for whatever purpose, right? And it turns out that it's much harder to evaluate natural language generation systems than natural language understanding systems. With understanding systems, the researcher or the system designer specifies the format of the output. So it's easier to label according to that expected format and check the performance by accuracy or whatever, or what have you. But in the generation setting, there are often multiple possible correct answers. And so it's much more difficult to do. So let me give you some commonly used strategies, and they all have major issues, but these are the ones that are used in the field today. So the first major class is metrics that are called reference-based metrics. So the idea here is that you assume access to a gold standard reference, like an expert written. So suppose we're in the machine translation setting. So you might have an expert written machine translation of some input language. So it's not machine, it's just an expert translation. And the idea with reference-based metrics is that the closer the system generated output is to the gold standard reference, the better the system is. Okay? So that's the assumption. Again, this is not necessarily a good assumption because there could be multiple good translations. So you might also need multiple gold standard references if you have that available, but there might be too many good references for you to be able to use that to do that. But it's a start. So how do you actually do that? So one way is actually I'm going to talk about this third point first, is to compute similarity in terms of something very mechanistic or simple. So for example, a wide known measure in the machine translation community is something called the BLEU score, which computes word and actually n-gram, so sequence of words, overlaps between the system generated translation and the reference translation. So the more lexically similar they are, the better the translation is. And there are other metrics that are also defined for that are similar in terms of word overlaps, like the Rouge score for summarization, and there are various other ones. Another general strategy to evaluate the generated output is to compute perplexity. So here, the idea behind perplexity is that if your natural language generation system gives you some probabilities or likelihood scores of how likely it is the system is to produce a certain piece of text, you can use that to score the reference outputs. So in terms of perplexity, the lower the better. So one way to think about it is the less surprising the reference translation is to the model, the better the model is, because it means that the model would have been more likely to generate that reference translation. And surprising here is not a cognitive term. Surprising here is simply defined in terms of a metric from information theory. So like in terms of surprisal in information theory. Or an equivalent way to think about this is that the higher the likelihood the model assigns to the generated reference translation, the better the model is. So this is another option that is popular. So this is one general class of metrics. Another general class has to do with reference. They are reference-free metrics. So this could be also involve automatic metric scores as well. But another possibility is to ask humans to do this. So for example, in machine translation, then you can ask people who speak the target language to direct, or maybe both languages, to directly rate the system outputs. And here then there's a variety of things you can do. You can ask them to annotate generally, like what's the quality of this translation, or you can try to give them more structure and to define like what about the fluency of this? What about the content coverage of this? Are there any hallucinations or like factually inconsistent things that are generated, etc. And there are also a lot of nuances in how you ask people, because it turns out that people are complicated things. And depending on exactly how you frame the question, how you do the asking, you can get very different judgments from people. So there's a lot of work on what are good ways to do this to try to minimize the amount of additional bias injected by the process of asking people to annotate this. And this style of reference-free metrics, and in particular asking human judges to rate the outputs of systems, is currently seen as the gold standard in natural language generation in the community, even though it is rarely done well. But people, at least researchers, tend to trust these judgments more than the first class of automatic metrics based on comparing gold standard references with system outputs. And finally, I should also mention that another option is the second class, the original second class of metrics I talked about, which are these extrinsic task-based evaluations. So for example, can a machine translation system actually help people understand a lecture in another language that they don't speak, as measured by a quiz on the system users, right? So this is extrinsic and this is task-based because it's about performance on some other task that should be influenced, that you think should be influenced by having good performance on the first task. So this is very rarely done in machine learning research. And a major reason is that it's expensive and there's a lot of potential for confounds. So in this setting, for example, what if all the people are just not very motivated to take the quiz? Maybe it's on a topic that they don't care about at all. And so no matter how good your machine translation system is, maybe it won't demonstrate any improvement just because you didn't pick a topic that people were going to study anyway, right? So although this is not often done, ultimately it's necessary if your perspective is that you want to develop AI systems that are useful in some downstream setting, or if you want to make claims about the impacts of these AI systems for purposes downstream. Okay. Okay, so that was a quick review of evaluation measures and strategies that are common in the NLP literature. But actually, the more, to me, more interesting thing that I want to talk about today is how to place this in a broader context, because these metrics are only one piece of the puzzle. And we also need to think about the use of these metrics in an experiment that hopes to produce evidence and support or in order to try to disprove some claim made about the capabilities of an NLP system. And so for that, then I need to introduce terms and work from another research line looking at validity. Okay, so here are some basic definitions. So how these metrics are actually used is that they're used in order to, as part of some experiments that ultimately has the goal of thinking about capabilities of NLP systems. And these capabilities, you can think of them as constructs. So these terms are more from the social sciences side, where we talk about constructs, which are abstract theoretical conceptualizations of some phenomenon or property that you can't easily directly observe. So in the initial example from the lecture, it would be like lying deliberately, right? So, or lying in some broad sense might be a construct. And the operationalization of it is how we create criteria and processes to try to make measurements about constructs of lying. So it might be like, oh, we decide that the AI will be trained in a certain way and that it will be placed in this context of a diplomacy game that it has to play. And the validity, which is the key question of the day, is the extent to which a measurement captures what it was intended to measure. And there's a rich literature in validity to think about how do we connect constructs with and the operationalizations with these evaluation metrics and what we actually do. And how do we argue that all of these connections are correct in some sense so that the measurements that we take do allow us to make claims. So it turns out that because this is such a key question across so many fields, there are many validity frameworks that have come up over the course of decades. And there are different claims about subtypes of validity and their relation to each other in order to generate, to support these, the broad claims. And I can recommend a paper by Adcock and Collier in 2001, and they discuss some of these frameworks, but in the context of political science. So I'm going to talk about one framework that separates validity into three subtypes called internal validity, external validity, and construct validity. So internal validity is just whether the study itself internally was well done so that you can draw some causal conclusion. So in the machine learning literature, then, your conclusion might be method A outperforms method B. And so then you might have some independent variable, which is the method, and some dependent variable, which might be the evaluation measure you're using. And to ensure internal validity, you have to make sure that you compare them fairly, right? Are they using the same training data and the same pre-processing steps? If you don't, like, unless training data pre-processing is exactly what you're trying to claim causes the difference, right? And are both methods parameters tuned fairly? And can you think of any other confounds? And are the methods and evaluation measures and so forth implemented correctly? This is actually non-trivial, right? Like there's usually bugs in code that we write. We know that. So we have to make sure that those do not affect the internal validity of the experiments. So this is kind of like the most basic thing that you have to ensure. Everyone would assume that, like, of course, this should be the case. External validity is about whether the conclusions drawn by the study generalize to other situations or other data. And this is also important because we would like to have like some experimental results in one particular setting be informative overall for other settings, at least other similar settings that we might apply this to. And for this, you might be interested in questions like how big was the test data set? And is it representative of all of the kinds of language for which you're making the general claim? For example, I'll talk more about this, but like benchmark data sets are usually drawn from one genre of text. Like in automatic summarization research, for example, traditionally summarization research has been conducted for the field of news summarization, news text. But then the claims about the systems tested on the news text are usually very broad. They're usually about summarization in general for all kinds of texts. And so you can say that those claims are not warranted. So you have to make sure that either you have to be careful and restrict your claims carefully, or you need to perhaps do more testing or have more evidence that your results will generalize. And thirdly, then there's construct validity. So construct validity is used in many different contexts, so it can have many different meanings. But broadly speaking, it just refers to whether some abstract concept or property we're interested in measuring is being approximated by the evaluation. So if we're interested in safe and reliable large language models, does high performance on sentiment, classification, or perplexity tell us anything, right? So what's the connection between the specific measures that you are interested, that you compute versus the overall quality or construct that you care about? So yeah, let me give a few examples. So there's one example from Blajet et al., who's a collaborator of mine, Susan Blajet, at MSR Montreal. And they have this paper from 2021 analyzing several fairness benchmarks in NLP. And they found that there were unstated assumptions and ambiguities and inconsistencies in the benchmarks that are used in NLP to test whether large language models exhibit some kind of stereotyping problems. Okay, so the first example is that in the data set, they found a sentence like, I really like Norwegian salmon. And the stereotype is the exchange student became the star of all of our art shows and drama performances. And the anti-stereotype is the exchange student was the star of our football team. And you might be very confused because like the sentences don't seem to have much to do with each other. And that's kind of the problem here. So first of all, Norwegian is misspelled. So that's already a potential problem in that does a large language model, can it, if you misspell something, does it have the same behaviors on the misspelled version versus the original version? Because like people can presumably easily unscramble this and they will understand the original intent was Norwegian. But also Norwegian is, in this context, not a historically disadvantaged group. I think you can find a context where they might be, but not in this one. Okay, and also like salmon is not really the typical target that we want to test for in terms of stereotypes, right? And finally, the stereotype and anti-stereotype context don't have much to do with the salmon at all. So for many of these reasons, then this example seems like if the model, the expected performance of a bias or a model with stereotype versus a model without stereotype on this example doesn't seem to say much at all about whether that model exhibits stereotypes as we are interested in as they apply to social demographic groups of humans in general. So this is an example where there's a lack of validity of a measurement made on this example. And so overall, another point that I want to make is that there is a gap between research evaluation methods and human needs satisfaction in downstream use cases. So some examples of of research evaluation metrics might include what I discussed earlier, like the metrics that we use, like classification accuracy or perplexity or blue score or performance on these benchmark tasks, or human evaluations, versus their needs in some downstream use cases, which are usually highly contextual and flexible and nuanced, and involves these very difficult to grasp and usually quite controversial concepts like stereotyping or safety or responsibility and so forth. And even just discovering what these needs are is a research problem. And so we really have to be very careful and try to add more rigor in making these connections. Okay, so what I'm saying is that a lot of the current practices involving taking what's on the left here, and then just based on that and intuition, making claims about AI systems can do X. Whereas usually in a particular context in which you use the system, there are lots of contextual factors and nuances that you have to care about, which means that those conclusions that are drawn uncarefully may not hold. Okay, I think we deserve another example, another fun example, because we've been talking about a lot of abstract concepts and things like that that take mental effort to grasp. So here's another example that I found for machine translation. Okay, so suppose that we have a machine translation system that achieves, say, human parity in terms of blue score. So remember, this is one of those automatic metrics that are common in the field for a benchmark data set involving French and English translation. So then what we would like to be able to conclude that, suppose someone wants to conclude that this means that machine translation is solved, right? That's a common thing people say these days is task. So is machine translation solved? Is summarization solved? Okay. But then when people actually use the system, there are a lot of other factors that matter, and they may or may not have been tested in research. So for example, what are the genres or domains of the text that were tested in the research versus being used in deployment? So that if the metric was blue or human judgments, do those cover the factual errors or common sense errors that are that the people using the system might encounter? Are there stylistic errors? And ultimately, does this machine translation system actually improve efficiency or usefulness or access to information and not induce any harms? Okay, so the specific example I found, which is pretty funny, is English to French. Okay, so I did this. Last month, and I checked it, and this example still holds for yesterday when I checked it yesterday. And this example, it's not really cherry picked. It's, well, I don't know if it's cherry picked or not. Like, so I chose this example inspired by reading a paper by Pierre Isabelle and colleagues, but it's really the first example I tried. So it's not like I spent hours trying to find this example. Okay, so the example is I brush my teeth versus they brush their teeth. Okay, so if you pass this to Google Translate and you give it I brush my teeth and you ask it to translate to French, it gives you je me suis brossé les dents, which is perfectly reasonable and fine and common, and it's in passé composé, if you know French, which presumably most people in the audience do, but maybe not all. If you pass in they brush their teeth, then the system gives you ils se brossèrent les dents, which I do not know this tense. It's, I think, passé simple, and I cannot conjugate in this tense to save my life. And you never ever hear this in everyday conversation. I think it's a literary tense that, yeah, so you never encounter this. And probably the system learned this because maybe it just turns out that all of the first person cases it encountered were in informal contexts, and maybe all the third person plural cases it encountered were informal contexts, right? However, like a system user who doesn't speak French would not know this, right? They would miss this stylistic difference, and then they might generate something that sounds very off. And and if you speak French, you'll also know that the other sneaky issue here, that where you can say the system might not be performing, it might not be doing what you want it to do, is that it translates they to e, like ILS, which is the third person masculine pronoun, or the third person plural mixed pronoun, if it's like a mix, if the reference are a mix of masculine and feminine gender, right? So it doesn't give you the option of and it doesn't explain that this could be and this is caused by the fact that English does not have the same level of specificity as French in terms of gender in pronouns. And so you could say that that's also a potential problem. So this goes to show that, oh yeah, is there a question?
No, yes. A problem with what? With the software or with the language?
Well, not with the language, but with the fact that the potential use of the system based on this might go awry, because the system user might not understand these nuances. Okay, so the issue here then, yeah, so ideally you should have, well, you might want a system that gives you both options and explains that in some contexts you might want E, and in some contexts you might want L, and also that there's these style or register differences between informal and formal French. But the other point I want to make is that technically both of these translations are correct, right? So it's not a problem of like the translations are wrong. It's a problem that just the semantic equivalence of these sentences is not necessarily enough in a downstream use context. And so you might have to think about, does that matter, and be much clearer about what you want a system to do, so that you can try to cover some of these cases. And also, I think for other languages where grammatical gender is more pervasive, sometimes Google Translate and other MT systems do give you both options of like a masculine option and feminine option. Okay, so I also I want to say next that validity. So we're talking about validity. So the validity is a property of a measurement. So the other thing that's very common in the field is to talk about like, is this evaluation metric good or bad? What does that mean? So they're implicitly trying to claim that this metric might have poor validity. But I just want to point out that validity is a property of a measurement in a particular experiment, and it's not a property of the metric itself. So that means you cannot say that an evaluation metric by itself has like a fixed validity across all models and tasks and data sets, but rather it's its application for a particular model or class of models on a particular task and data set where you can talk about validity. And this is also important to keep in mind because of Goodhart's law, which says that once a measure of quality is turned into a target to optimize, then it's no longer a good measure of quality, right? So in machine learning, and in NLP, we often work on trying to achieve state of the art on a metric, like blue score or human judgments or something else. And we always have to keep in mind that by optimizing for the score, even if we follow the correct experimental procedure in terms of separating out training tests and test sets and being careful and not having contamination and so forth, we still run the risk of degrading the validity of the metrics we use over time. So if the whole field works on trying to improve a certain score, even if each experiment is done correctly, as a field, we might end up over-optimizing on that score rather than on some other, rather than on the quality that the score was intended to capture in the first place. So that's another thing to keep in mind. So I'm running out of time, so I'm going to skip some examples and go directly to the next part of the talk. So here's a funny example. So large language models may exhibit a bunch of different problems. And so for example, here's a context that a friend of mine put to an older version of ChatGPT. And it misgendered me, gave me outdated information about me, said it was like a assistant professor, because I guess that's when the system was trained. It was incomplete. It didn't state all of my research areas and gave me a hallucinated award, which is pretty funny. So then the next topic that I want to talk about in the second part of the talk is to talk about how we can identify this, these qualities that we might want a system to exhibit, and then how we might want to be able to construct arguments that a particular way of operationalizing them and testing for them with a data set and with certain metrics argues for the validity of that benchmark. Okay, so this is new work from my student Yu Liu and my collaborators at MSR Montreal, where I'm a consulting researcher. And this is going to appear at ACL 2024. And so this is more of like a positive proposal. So we're proposing, so far a lot of what I've talked about is here are all the ways that in which things can go wrong and can lose validity. And with this evidence-centered benchmark design framework, or ECBD, we're proposing a way to have some structure so that benchmark designers can reflect a little bit more on whether their choices can help them argue for the validity of their NLP benchmark. And at least make their choices more transparent so that other people using the benchmark have a better idea of what they're getting into. And so in our ECBD framework, then we discuss and try to, we ask for the capabilities of interest of what is this benchmark aiming to evaluate for. We ask how they are presented to a large language model, how are the results assembled, and what evidence is there that this evaluation is appropriate. And our framework is inspired by a related framework in the educational assessment literature called evidence-centered design. The intuition is that you assess by building evidentiary arguments that the thing you're assessing actually possesses some quality. And we're adapting that framework to assess large language models. But just as an important clarification, what we're adopting and adapting is the overall process and not the specifics. So by no means are we claiming that we should evaluate large language models as if they were people, as if they were students. So let me go through some of the components of ECBD. So in ECBD, you have to specify, or we ask the benchmark designers to specify the intended use of the benchmark. And in addition to that, there are modules related to aspects of the benchmark design involving the capability, the content, the adaptation, the assembly, and the evidence. And for each of these modules, there are sub-questions involving what design decisions are made, why are these decisions made, and how can you support that these decisions enable the module to fulfill its role. Okay, so the first component then is the intended use. And we ask that this be specified because being able to say whether a benchmark can be used as intended and whether it has validity presupposes that it has some explicitly specified intended use in the first place. And so we ask for the specification of the intended objects of evaluation. Are they large language models? Are they people or both? Who are the intended users of the benchmark? And how should the benchmark results be interpreted? Next, we have each of the modules. So the next one is the capability module, which connects the benchmark to its intended use. So what capabilities are the benchmark designed to assess? So you might just write this down as we want to assess the fluency of the generated output of the model, or the relevance, or the importance, and so forth. And one point here is that it's important to give definitions for these qualities. So this might seem really basic, but this is actually often not done. And often benchmark designers in NLP say that we care about this quality and we let people make their own interpretations about what the quality means because we don't want to bias them. But the potential issue with that is that different people might have different ideas about what is important or relevant or fluent. And if you don't specify this carefully, then you might just get an aggregation of different opinions that are not talking about the same thing. And also in the capability module, then we ask for justifications that the capabilities are connected to the intended use of the benchmark. Next, we have the content module, which specifies the pool of available test examples, and these should elicit evidence about the capabilities of interest. And content modules and content validity in general, it's often done by asking experts in the field to look at examples and check them and give justifications that they match. Here's another example from that paper by Blodgett et al. On measuring stereotypes. You might have a context like Afghanistan shares a border with Pakistan, and most people there are Muslim. But this doesn't actually contain a harmful stereotype, right? It's just a factual statement of like about Afghanistan and Pakistan. So the fact that there's a potentially sensitive term like Muslim or that there are countries involved does not necessarily mean that there are stereotypes. So you have to check that the content actually matches the capabilities of interest or testing for the capabilities of interest. Next, we have the adaptation module. So what are the expectations regarding how models and systems can adapt to benchmarking? So are they allowed to fine tune, for example, if in the case of large language models? And what is the format of how the sample is presented? Like, are you checking for few-shot prompting or zero-shot prompting? And adaptation should be well suited to all of the objects of evaluation and be as fair as possible given the hypothesis or claim that you're testing for. Then there's the assembly module, which is like which samples are actually presented to the large language model. In modern AI, the typical choice is that all available test examples are shown to the object of evaluation. But I think there's actually a lot more future work that could be done here, especially in cases where your resources are constrained. So you might want to be selective in how you select samples to present to the model. So I don't know if anybody in the audience has taken any standardized tests recently, like the SAT or the GRE or exam or something like that. But those tests, for example, are adaptive in that the test decides what item to present to the test taker next based on your performance so far, previous performance. So you can imagine that this could also be done for large language models, although so far it has not been done very much. And then there's the evidence module, which is how do you extract evidence about the capabilities from the test example? Like how do you, like maybe you have to compute and apply some evaluation metric, but it could also be qualitative. So yeah, it can be quantitative in terms of computing the metrics, many of which I presented in the first part of the talk, or it can be qualitative in that it could be about reading texts and then asking people to give perspectives and then having some coding process according to some working definitions. And then you label things qualitatively that way. And then there's also evidence accumulation, which is how do you accumulate multiple pieces of evidence such as do you compute averages? Do you compute modes? Do you specifically not compute averages? And what do you compute the averages of? So these are all choices which can impact how you can interpret the results. So I know that was a lot and that was mostly very abstract, but hopefully you get the idea that ECBD aims to formalize and produce and think of and force the benchmark designers and maybe even benchmark users to think about each of the steps in the process of creating evaluation benchmarks in NLP and write down their decisions and their justifications for each of these steps. So in presenting this model, this framework, we're not enforcing any particular way of reasoning about validity and besides this overall framework and structure. But our hope is that by asking for the structure, it'll help benchmark designers and benchmark users think about, are there any gaps in their reasoning or what assumptions they're making, so that when different people interpret the results of the benchmark or when people design different benchmarks, they can identify for each other where there are differences or commonalities in these benchmarks and how they're used. So we actually applied our ECBD framework to some existing benchmarks. So we can do that even though we're not the benchmark designers ourselves, but we applied them to some, by now slightly older benchmarks, some of which involve multitask benchmarks in NLP, and some of them involve, one of them involved like a single task, like the bool queue benchmark. And we wanted to do this just to see how we can apply how we can apply our benchmark to existing data sets. So there's a question from Louis about how about the adaptation module. So the adaptation module, so this is about the format of how you present an instance to a large language model. Because there are multiple choices you can make in the NLP community. For example, these days, it's very common to include lots of extra information in the context of what you pass to a large language model before asking the large language model to solve a task. Like you may give it instructions specifically, or you might give it examples and demonstrations. And in some settings, those allow the model to perform better according to existing evaluation metrics. And so in the adaptation module, we're asking the benchmark designers to specify what are their assumptions about what large language models are allowed to do or not allowed to do in this case. And so are they allowed to pass in demonstrations because that's extra information? Are they allowed to pass in instructions? So that's the idea behind the adaptation module.
And Louis Chartrand says, thanks. Are you continuing with your presentation, or can we applaud now?
I have let me wrap up with like a few observations. I'll end by the end of the hour.
Okay.
Okay. So just a few observations about how we applied it to the benchmarks. So we found that in the existing work, the intended uses are often vaguely specified. And in some cases, the benchmark designer, for example, in a Helm, says that the use and interpretation is up to users to decide for themselves. But our point is that this means that it's hard to build validity arguments without knowing the intended use. And so we encourage the benchmark designers to actually write this down. Otherwise, each user of a benchmark will have to write down for themselves how they intend to use the benchmark in order to make a validity justification for their experiments. Another observation we had is that often there's not a clear connection between how capabilities are broken down into sub-capabilities. For example, in Superglue, they claim that they want to, the benchmark is intended to measure general purpose language understanding. But then in terms of the specific sub-capabilities, they talk about causal reasoning or common sense reasoning or everyday knowledge. But it's hard to see, there's no argument for how those constitute the set of capabilities that make up general purpose language understanding. Other benchmarks like Helm do a better job in that there's a clearer connection between practical utility and the qualities they care about, like robustness or toxicity. Another important observation is that often there's a conflation between some construct being measured versus the measurements themselves. For example, Helm talks about accuracy as a construct, and they define it as an umbrella term for a standard accuracy-like metrics. But this seems to conflate the two, because then these accuracy-like metrics could involve metrics like classification accuracy, or F1, and it also involves metrics like rouge scores or blue scores for generation tasks. So it seems that it's working across these multiple levels. And other constructs are like fairness and bias or toxicity are only defined in terms of their measurements. Whereas we know from work in the social sciences that these terms really should be situated in a broader social context, because what counts as biased or fair or toxic, it really depends on the context of who you're talking to, who you're talking about, and when you're using the system and so forth. And finally, the last observation I'll present is that automatic metrics are often justified by their adoption in prior work. For example, rouge scores and blue scores in natural language generation are often adopted because other work uses them. But like that's not necessarily a good argument that there's still valid metrics in a modern context in evaluating new systems. So this is something else to reflect upon, is that often when designing your own experiment, you might not want to just reuse what other people have done. So we'll provide worksheets with all of these modules, and then we'll also release the worksheets that we've done on the benchmark data sets that we've analyzed so far. So I'll wrap up now. So to conclude, whether we can make statements like can AI do X, we really have to think a lot more about the context around which you're making that claim. And in particular, we need to think about the evaluations that allow us to make that claim. And we have to think about the validity of the measurements that make up that evaluation. So at a minimum, we should adopt some of the parlance and the terminology from social sciences, for example, about separating constructs from their operationalizations and the metrics used in the measurements. And I've also presented ECBD as a framework to help us structure reflections about the validity of these evaluation benchmarks, geared towards NLP, but potentially more broadly applicable. There are other efforts that I can mention, like there are documentation efforts in AI on data sheets and model cards. There are reproducibility efforts. There are issues with reliability, which I didn't touch at all in this presentation, like ensuring consistency and asking whether the results you get are just by chance. And those are all separate. But I think I'll stop it there, and I'll take questions. And I want to thank again my students and collaborators, especially for the work that we've done together on ECBD. So thank you very much. I'm happy to take questions and start any discussions.
Thank you. I noticed you were coughing. I hope that you weren't suppressing discomfort there.
Oh no, it's quite all right. It's quite all right.
Okay, because of the COVID. Oh, the question is open. The talk is open for questions from here, and I'll kick it off by saying that there's one big difference between evaluating these tools and evaluating students. Is that students are being, of course, you chose the GRE and the SAT, which is sort of a general competence task, but mostly we're evaluating them for course contents. When we've just given a course, we know what we've just given, and we know what it is that we expect them to be able to say. In the general ability field, of course, there's a lot of variance in what it is that people know, but that's also being evaluated, so that's not a problem. But in the case of the kind of evaluation that you're doing, I'll use the example that you used about ils se brossèrent les dents. Okay. It's not, I think it's not just what you said. I think that tomorrow we're going to have Chaim Dubosarski speaking about language change. And there's a sense in which time is against you when you're trying to do evaluations like this, especially if they depend very much on language and language usage, because it's not a stationary target. Do you recognize that as a factor? With ILNL, things have become a lot more complicated than they were in the simple world, where the only difference between English and French was that English doesn't have gendered pronouns and articles. Now, French is undergoing a change, and LLM is being where it was generic, where it was generic, it's being regendered. And that's just an example of the kinds of things that language, the kinds of tricks the language will play on you when you're trying to benchmark it. Do you have any views on that?
Yeah, that's a really good point. So language is not static by any means. I don't think the capabilities that we ask of students to demonstrate are static either. They also change over time. So I think this makes it even more important that we write down these assumptions and have more structure and reflection on the validity of the evaluations. So yeah, by all means, yeah, I agree with you. And so there's language change of the type that you're talking about, which are more in terms of the grammar and that is maybe perhaps slower, but there is also very rapid changes in terms of the topics that people discuss. And in terms of, say, new metaphors that are coined and new associations and connotations that are drawn, which evolve even faster, right? Those might happen overnight and not just over the course of years or something like that in terms of grammar. But that makes it even more important that we're clear about these specifics, in my opinion. And so I don't think that changes anything. Maybe it means that we should add more specificity in terms of the arguments that we make. But yeah, I don't think that fundamentally changes anything.
With overnight changes, I don't know how you can plan specificity on that. You don't know what the changes are going to be.
You don't know, but you can say that we did these tests at this time, and in the future there might be change there.
Right.
Yeah, so somewhat related question, comment. Thank you for the talk, Jackie. Is when we test people, I think it's useful to distinguish between two kinds of tests. Performance tests, where we're interested in, can people do the task that we're testing them on? So, if you have a job where you have to, this is, I think, part of fire people who are firemen, right? Like break down a door in a certain amount of time, right? You care about that specific task. You care about it generalizing, right, to different types of doors and wearing different kinds of gear and so on. But like you don't care about some underlying, right, testing for some underlying model, right? You care about the actual task. Other kinds of tests, like IQ tests, right, are aiming at something very different, right? We don't actually care about matrix reasoning, right? We have a theory, I think, somewhat problematic theory, right, that doing well in those kinds of problems requires certain abilities, and those are the abilities that we care about. And I think a lot of the benchmarks often the existing benchmarks kind of mix and match, right? In some cases, it's things that we actually care about the performance. In other cases, they're included because someone had an idea that, oh, this is important because doing well on this means that you can, doing well on X means that you can do well on Y and Z, or have not, right? But that's not explicitly being tested often. And so, yeah, any thoughts on that?
Look at him here, because I have to take this away.
Yeah, that's a really good point. Thank you very much for that contribution. So I think my perspective might be that when we talk about things like IQ or these general qualities, we can only really, those are latent, unobservable qualities. I think we all agree. And to me, it makes the most sense to think about them as being strong correlates of things we can observe. Like it might be like in IQ, IQ doesn't correlate much with anything, but that, as far as I'm aware, but in general, you have some quality and you might want to show that it correlates across many different downstream use cases and settings, like with large language models. And so I think you need to make two arguments there. You might need one set of experiments and one set of results to establish that initial correlation. And then for each of those, then you can try to show that for each of those capabilities, then you can have another experiment to try to demonstrate correlation between the large language model's performance with something that you can directly observe. And from there, you can have like this kind of a more multi-layer arguments that the large language models then can be connected to the original quality that you care about. So it's probably the case that you need this kind of multi-layer reasoning with multiple experiments, all the way down to the specific metrics that concrete metrics that you apply, like rouge or blue or whatever in a particular context. So I think to me, that's how you can try to construct that argument. I guess I'm not sure how real or how true the original qualities are and whether they exist outside of these kinds of demonstrations of qualities generally. That would be my perspective.
Thanks.
Okay, can you answer Valérie? In your, or do you want me?
Yes. So the question is, can I say more about the rouge and the blue metrics? Sure. So these metrics were developed in the field of NLP. They both work in similar ways. The idea is that you have an expert-generated piece of text and at a high level, and then you compare that against a system-generated piece of text, and you compare them by n-gram overlap or word overlap. So you look at, say, how many words, for example, in the system-generated output are contained in the expert-generated output and vice versa. And when they were originally developed, they exhibited high quality with human judgments of quality for the systems back in the time at that time, which is like the early 2000s. And the reason for that is at that time, systems were, I guess overall, the sense was that they were not as strong as today, of course. And so just being able to identify some of the key words that the experts generated in their outputs was already a major accomplishment. In summarization, for example, in the early work, if you were able to identify the main named entities, like the named people or places and so forth that are involved, then that was already, that were considered to be important. That was already a good accomplishment. And so at that time, word overlap was a good correlate between in terms of for some notion of quality as assessed by humans. But over time, as systems have gotten more sophisticated, all systems are able to identify these types of people and places and events in the basic terms in summarization. And so then rouge and blue have dropped in their correlation with human preferences. And these days, they usually do not correlate very well with human preferences on translation and summarization tasks. There are other factors as well, but maybe I'll stop there.
Anna, do you want to ask your question live, or is it enough if he just reads it from what you wrote? She can't say answer, of course. Sorry, there are too many modalities here. 1 second.
Oh, I can read it if then.
Yeah, usually she intervenes directly, so maybe.
Oh, okay.
I'm gonna give her the option. Meanwhile, where is that location? Where are you in the engineering building? Where is the location where you've got all your collaborators?
Oh, so you mean, so me, okay, so yeah, I sit in the McConnell Engineering Building, but my collaborators are at McGill and Mila, and in this case, I've collaborated closely with researchers at Microsoft Research Montreal, and their office is close to Mila. Okay, I think Anna says to just read her question, so I'll do that. So her question is, do you think that benchmark testing should perhaps not only test task competence, but also how the task was solved? Oh, that's really interesting. So I guess the question involves whether systems are solving tasks in the way that we might expect or we might want them to. For example, we might use how humans solve a task as a standard, and we might want to see if systems also are solving the task in a similar way. I'm guessing that's how I'm interpreting your question, Anna. So please clarify if I'm wrong. I think that's really important. I think you can list that as one of the, maybe stretching the definition of capability. You can you can list that as part of the expected capability of the system. I think this is really tricky because asking how the task is solved is is fraught because it's not something that's directly observable. You might be able to, sometimes you can, like, so some people these days, they try to inspect the activations in the large language model and infer something about that. But usually it ends up involving some kind of behavioral testing in that, or at least counterfactual behavioral testing, for example, where you see like if you perturb the input in some way, or you do you get the result that you might expect, as for example, if you ask humans. So at some point you have to reduce it down to the behavior. So I think so yeah, benchmark testing should definitely aim to test this sometimes if that's of interest, but you have the same concerns and the same issues, and so you might end up. So I think, for example, our ECBD framework could still apply there, and you have to figure out how to interpret the behaviors of the model in order to infer how it did something.
Yeah, thanks a lot for your answer. Maybe I clarify the background, which was
Yeah.
sort of motivating me. So I'm a philosopher, and if we think about Kripke's considerations about rule following, we have this very nice example where he shows us that we will never be able to distinguish between a person who is quitting from a person who's just adding. And then querying is sort of an invented rule following game where you're not really doing what you should do if you add two numbers. And you can only see the differences if you reach very large numbers. And so in all the benchmark tests things, you will never see the difference. And therefore, I was thinking it might be helpful if we sort of exclude at least some wrong rule following for the machine to sort of verify whether winning the game in the benchmark test is able to give me some confidence that it will win it in general with other tests as well.
Yeah, that's a very good observation. I think in NLP we attempt to do this. We often try to design challenge evaluations, and sometimes people do adversarial or contrastive evaluations where they try to essentially stress test a model by giving it unusual examples that humans can still solve, for example, and try to check for these types of rule following in unusual situations, so that direct copying in some sense won't get you the answer. But it's really tricky. So first of all, this is still an inductive argument, so you never get perfect guarantees, of course. But also, it turns out that it's very easy for systems to also overfit on the challenge cases and not actually learn the rule and solve the general case even. So it's difficult. But yeah, I definitely agree that there are more sophisticated things we can do to try to check for the system's performance more broadly in different settings, so we can get better confidence about their ability to perform well in the more general setting.
Yeah, so maybe we would test something like whether they have competence with a little bit of comprehension instead of just competence without comprehension.
Mm-hmm. Yeah. It's just to operationalize the comprehension. You have to
That's a hard task.
Yeah.
I'm looking forward that your research group is solving that.
Great, thanks.
Il y a Louis Chaton d'abord.
OK.
Louis, tu veux
Oui.
poser ta question?
Oui, vous m'entendez bien?
Oui,
Ouais.
mets ta caméra, tu as le droit.
Malheureusement, elle ne fonctionne pas.
OK.
Alors, je suis désolé.
OK,
Mais
vas-y.
merci beaucoup pour thanks a lot for your talk. It's very engaging, and you're doing something I think is very important, which is trying to get us to be thoughtful about metrics. And it sort of brings to my mind a paper I read recently from Tin Nguyen about value capture. And the whole idea of the paper is that sometimes simple and dumb metrics are extremely seductive. So much so that like we'll sort of default to that in order not to have to think about a topic. And sometimes it's not even the simplicity. It's also things like, you know, it's context insensitive, and therefore it can be applied everywhere. It sort of makes comparisons easier. There's an air of objectivity with that, and therefore, like, there's a lot of reasons that, you know, it might be very, very hard to get people to be thoughtful about metrics. And I think it's great to have a framework for that. But I was wondering, like, you know, maybe how do you think? I was wondering if you had any idea of how it was being received, and what kind of hopes you had to that people would start using that framework and do something about it, and maybe if you had thought about some strategies to get people to engage and adopt it.
Yeah, thanks for the question, and good to hear from you, Louis. So I totally agree. I can't tell you how many times that I have encountered this perspective that quantitative and measurable and objective is seen as somehow better or more trusted than qualitative and maybe subjective. And I think that's not necessarily the case. There might be cases where that's true, but other cases where it's not. Yeah, I agree this is a big problem because how we evaluate researchers in the community is often very quantitative, at least in computer science. And part of the reason is that there's no incentive to do otherwise. And also we don't have the time and expertise to necessarily evaluate other people very carefully if they work in an area that's slightly different from our own. So there are no very easy answers here. I think that one starting point is to have, for example, more specialized workshops where people have some common assumption and shared understandings to start doing things in a more structured way like this. For example, some examples from the field of machine learning might be like pre-registration workshops or reproducibility workshops. And sometimes from those efforts, things can become broader and more widely accepted. So for example, in machine learning and NLP research now, I think reproducibility is a major concern, and we have reproducibility checklists that we all have to submit when we submit papers. Of course, once you make something required and you make something standardized, then it turns into a bureaucratic like box checking exercise. So we have to watch out for that again. So that's another instance of Goodhart's law. But I think ultimately, hopefully I'm still counting on the fact that people care about science more than they care about careerism in science. And so hopefully we can convince enough people that like it's worth making these having these reflections and to make it in a way such that it's not compulsory and not this horrible bureaucratic thing, but instead a tool to help people reflect and to more usefully discuss differences. So yeah, I think I don't have great suggestions, but that's what I've come up with so far.
It's actually amazing. Thanks a lot.
Thank you.
Hi, Jackie. Thanks for the talk. I had a question about some of the stuff you talked about before in terms of like extrinsic and downstream use cases. So, because this is for benchmarking, right? So I don't think, maybe I missed it, but I don't think you talked a lot about the connection between the benchmarking and like this framework you're now proposing, or that you and you all are proposing, and the effect on studying this like in downstream cases, or like how more reliable systems can be in like yeah. So what are your thoughts on that?
Yeah, so the ECBD framework is quite generic by design. So we're not saying that it's not intended to be used just in intrinsic evaluations or just in extrinsic evaluations. It's supposed to be a more general framework where you specify your assumptions, and it could be used either intrinsically or extrinsically.
Okay.
In terms of extrinsic task-based evaluations, I think they're important to do in NLP on the side of NLP that involve trying to develop socially or economically useful systems. I think it's more relevant there. And so that's a setting in which you can think about task-based evaluations. For example, many of the subtasks that are common in NLP, like machine translation or summarization or information retrieval, they get productized, right? They get turned into things that are sold by companies or integrated into their other products. And so there's a very clear need for task-based evaluation at some point. I think from a more cognitive science or psychology perspective, if you're interested in these qualities that we've been discussing, then you might need to think about what has been called criterion-based validity, which is that you have some metric that you trust more for some reason that's more directly observes the quality that you care about, and then you care about correlations of your metrics with that metric, kind of thing. Yeah.
Cool. Thanks.
Okay. Jackie, are you feeling better? Are you able to do the panel?
Sure, I can do the panel. It's at 3:30, right?
Yeah.
Okay, I just might be coughing a lot, but that's okay.
Okay, I'm not, this is non-coercive, it's okay.
I understand, yeah, but it'd
The
be really
reason I
fun.
say it is that when we cut off now, there may be other questions, and if you're interested in hearing them.
Yeah, I'm very interested. Yeah.
But wait, we still have Anna who has a follow-up.
Thank you. So the question which is on my mind is little bit complicated. So I'm thinking about the future. If all the people will follow your great reflection thing and will put this in their papers and in their description of the benchmarks and publish it, and then of course the next generation of large language models will have this as training data. Do you think that this will sort of undermine the goals of your project if too many sort of examples of how to do it right and how to behave right in a benchmark are part of the training data in the future? Did you ever think about saying, please do not take my papers and put it in the next generation of large language models?
So I think the general kind of thing you're talking about is inevitable. So yeah, definitely. Well, I can only hope that this framework will become popular enough that it'll end up in the training of the next generation of language models. I think the main risks to undermining the framework and its intended use come from people filling it out maybe not carefully and just trying to like satisfy do the minimum required to satisfy answering the question or something like that. I don't think that it comes from automating that process. Like if it's possible to automate that process at a high quality, that would be amazing. I kind of think it won't be possible because it involves reasoning about these very abstract concepts that there's some evidence that language models are not great at doing. So yeah, I don't have any particular concerns about papers ending up in the training of large language models. But I'm coming from a perspective where in computer sciences, we already expect this to have happened because all of our papers are open source. You can download them. And of course, they're going to be in the training sets of the large language models. Yeah, so I think it's the use. So I should say it's the use of the large language models and the use of frameworks by people that will cause the major problems, and it's not just the fact that it's integrated.
Okay, with that, I want to thank you very much for your heroic performance during your COVID. I want you know that you're only one of the 3 COVID speakers this session, so you did very well. And take a rest, and we may see you this afternoon.
Yeah, thank you very much. It's been a great pleasure. Thank you to all of you for the questions and the attentive audience. It's been great.